Alright, here's our third video to help you finish off the practice test for Unit 1. So we'll show you 20 that you can do with your calculator or by hand, and then 21 will show you, since this does say with the calculator, we'll show you how to do it with the calculator. And so for here's number 20. So before we can do anything, we need to isolate the absolute value signs. So we're going to go to -8 to both sides like this. So 13 minus 8 is 5. Excellent. And then we also need to get the 5 to the other side. So when it's right next to it, it means times. So we're going to go ahead and divide 5 over to the other side. And so that's going to become a 1, isn't it? So we have absolute value of 2x minus 9 is equal to 5 divided by 5 now is 1. We're going to split it off into two equations. So 2x minus 9 is equal to 1. And 2x minus 9 is equal to -1. Beautiful. Okay, so then next we're going to go ahead and solve for x by adding 9 to both sides. So we get 2x is equal to 10 divided by 2, and we do get x is equal to 5. Awesome. And then we're going to go ahead and add 9 with a -1, so 9 minus 1 is 8. So we get 2x is equal to 8 divided by 2. Pause me. Anytime, pause me, remember, to make sure you try it on your own first. 8 divided by 2 is 4, to make sure you know what you're doing. So rewind, pause me, and try it on your own, and then watch the video and see how you did. That's the best way to learn. Okay, so we get 5 and 4 as two solutions. So if we plug a 5 in to make sure it works. So 2 times 5 is 10. 10 minus 9 is 1. And then 1 times 5 is 5. And 5 plus 8 is 13. It does work. 5 works. 4 times 2 is 8. 8 minus 9 is -1, but the absolute value of -1 is a +1 times 5 is 5. And then 5 plus 8 does equal 13. Also works. So 5 and 4 both work. Check and check. Awesome. Okay, so number 23, we're going to give that a try. But we're going to try using our graphing calculator this time, since it does say you can use a calculator. You can still solve by hand if you want to, but you can also use the calculator. And so what we're going to do there is we're going to go ahead and type in the left side and the right side. So the right side, here we go. And I know what you're thinking by looking at number 13 or number 21. That you have a negative on the right side. Absolute value can't equal a negative, but when you minus the 12 and then divide by -3, it will become a positive number, so it will work on that side. In fact, why don't we do that? It'll still work with the graphing calculator. So I'm going to go to minus the 12, and so -15 and -12 is -27, and then we're going to divide by a -3, and that's going to make it a +9. So then we're just left with x plus 9 is equal to 9. Really, you can almost do that in your head now, right? You can add 9 and minus 9. So you should get 18 and 0. But let's double check and see if that's right. So in fact, I'll even use the original. Ready? So we're going to use the original. Here we go. So get out your calculator there. We're doing number... Whoa. There we go. Zooming in. That's it. Okay, there we go. Okay, so then, excellent. So we have a -3, and then we have math button. We have the absolute value of, excellent. And then we have x plus 9, so we'll type that in, x plus 9. And then we have plus 12, so plus 12. And then we have equal to, equal to -15, and so that's going to be the right side of the equation. So basically you're doing like y1 equals this and y2 equals this, and we're seeing where they intersect, okay? So now we'll go ahead and put in the -15 there, and then we'll push graph, and we just want to see where they intersect. So it looks like it intersects nowhere. What the? Oh, it's because it's -15, right? And y equals -15 is like way down there, so we got to adjust our window. So let's go to a window, and let's change our y minimum now to -15 so that we can see down that far, maybe even -16, just to go one more number. Okay, so now here comes negative. That's it, bam. So it looks like we might have two intersections there. So let's see the first one. Ooh, so if I push the up arrow, you'll see that 0, negative 15 stays there the whole time. If you also want to use the second calc intersection function, we can also do intersection, first graph, second curve, and guess. And it says 0 and then y equals negative 15. So that means that one of our solutions then is that x equals 0. And we're guessing the other one is negative 18 is what I'm going to hypothesize, because if you make this negative and then you also minus the 9 over, you'll get negative 18 when you're doing the two equations. So what we'll have to do is we'll have to go ahead and scroll to the right. We could change our window to negative 18, but also if you just scroll, just push the trace button right here, and then just scroll to the left, you'll be able to, it'll move for you. And so once we get all the way down where x equals negative 13, negative 14, negative 15, 16, 17, there's the intersection. There we go. So we can see the intersection. Those numbers are kind of in the way actually, but it's at negative 18. And so it's also negative 18, negative 15. But if you're not sure, you can go second calc. I think it intersects about there. So we'll go intersection. Again, that was a second button, which is right here, and then calc. And then intersections option number 5. So then we'll go first curve, second curve, guess, third curve, bam. So that is negative 18, negative 15. There's still a line in the way, so I'm going to move it a little bit. I'm going to change my window. There we go. So I'm going to change it down to like maybe, I don't know. So we want to get further down there so we can actually see it. So maybe negative 20 is your y minimum there. So we'll graph that again. And so we can see that intersection clearly now. There it is. Awesome. And so then if you scroll down, you'll see that x equals negative 18. That's our other solution. Boom, there it is. You're still not sure? Okay, second calc, intersection, which is option 5. First curve, enter. Second curve, enter. Guess right there. There it is. X equals negative 18 is the intersection. So that's our other solution. And so both of those work. Boom and boom. Okay, you can graph the following by hand or using the graphing calculator. So 22. So if you can remember by hand, this just means up 3. And this just means opposite what you think, right? So instead of you thinking negative, which is left 4, it's actually going to be no. It's actually going to be right 4. Because 4 for x minus 4 is 0. So we're going to go ahead here at 0, 0. That's the parent function like that. So we're going to do some shifting. So we're going to go up 1, 2, 3. And then we're going to go over to the right 4, because right there means right 4, negative 4, right 4. So we're going to go 1, 2, 3, 4. And then just going upwards to the right, upwards to the left. Now if you do want to double check on your graphing calculator, you can. We'll show you how to do that. So you go to y equals, and you go ahead and clear that and clear that. So we're going to do the absolute value, right? So we're going to do the absolute value. There we go. So we're going to go ahead and do math button over to numbers, and there it is. ABS stands for absolute value. So the absolute value of x minus 4, so x minus 4, right arrow, and then plus 3, plus 3. Okay, perfect. So we'll push graph. And so I got to fix my window, so we're going to go ahead and go to fix my window there. So we're going to hit the zoom button, and then we're going to go just to zoom standard. That fixes the 10 by 10 graph. Zoom 6. Everyone say zoom 6, zoom 6. So there, we can see it. There it is. If we push trace, you can see the vertex is a shift to the right to the 4, and then up 3. Approximately there. Awesome. Okay, so then that's how we do it with the graphing calculator. We're going to do this next one just by hand, because it is that easy. Oh, actually, this will be a little bit tougher. No, we can do the slope. So negative 2 over 1. But first, let's go ahead and do down 5, right? So down 5, so we're going to go 1, 2, 3, 4, 5. And then we're going to do, we think right 1, but it's actually left 1. So down 1, 2, 3, 4, 5, left 1 is our vertex. Now that negative means it's going to go ahead and point downwards, or in other words, that negative means upside down. Right? So upside down is what we're going to do from this point now. So and then the slope is down 2 over 1, right? The slope for this absolute value is in front of the absolute value, and so that's a slope then, that's a slope. So that means we're going to go down 2, and then over 1, as well as down 2 back 1, because it's symmetric, because it's absolute value. So we're going to go down 2 over 1, down 2 over 1, and then down 2 back 1, down 2 back 1. So it's going to be narrower. And there we go. Excellent. And that's the right answer for number 23. Flip over to the other side. So cube roots, you guys, remember cube roots. Still shifting, still shifting. Whoops. 24, still shifting. Is that 25? Oh, there's 24. We got it. Okay, so that is a cube root there is what we're going to... No, that's just a regular square root. Beautiful. Okay, so again, outside the absolute value or the radical is your up or your down. So that's down 3. Inside is opposite what you think. So you think right 5, but it's actually left 5. So we're going to go down 1, 2, 3, and then left 1, 2, 3, 4, 5. And then with absolute value, with radicals, you go over 1, up 1, and then over 1, 2, 3, 4, up 1, 2. And so that just stems from the parent function, which was right here, over 1, up 1, and then over 4, up 2. So we're going to go ahead and that's just shifting to the left 5 and down 3. So we're going to go up and to the right. Beautiful. So we can show you on the graph and calculator on the next one if you want. So that one should be, up 4 and not left, but right 2. So we'll go ahead and plug that in there for you to remind you how to do square roots. So with square roots, we're going to go ahead with square roots. So you're going to push You're going to push the second button, and it's actually right there with the x squared. There's a square root symbol. Okay, so there's square root of, and we're going to do x minus 2. Now this is a little bit tricky part now, x minus 2. So you want to do the right arrow to get out of the radical, because that plus 4, this tricks people on the test all the time, that plus 4 is outside of the radical. So plus 4, there it is. So make sure that number's outside of the radical, because now it'll go up 4. So we're going to shift up 4, there it is. So that's going to be, it's going to be a up 4 and then right 2. So on our graph here, we're going to go ahead and go, so we're going to go right 2, 1, 2, up 1, 2, 3, 4, and then over 1, up 1, over 4, up 2. Because the square root of 4 is 2, so over 4, up 2. Okay, so there's our graph there, excellent. So then another way to check if you're really struggling when you're graphing these, if you also want to go to second, and then table, second graph, second table, and that's going to give you a list of where the graph starts at, which it looks like it's at, over 2, up 4, and then over 3, up 5, which is over 1, up 1, and then we've also got over 6, up 6. And so you can use those to help you graph it too, which is awesome. Okay, so then for time's sake, just to check your answers, well, let's show you cube root. So with our cube root function now, cube root, so cube root looks something like this, where you have 3 dots in a row diagonally, over 1, up 1, over 1, up 1, and then it kind of goes up and through, just like that. So that's what a cube root graph looks like. And so at the center, 0, 0 is what that would look like, right? What you're going to do now is you're going to shift down 5, 1, 2, 3, 4, 5. And then that plus 1, you think right 1, but it's actually opposite, left 1. So you put a dot there. That's the center of your cube root. And you're going to go over 1, up 1, and down 1 from the center, back 1, down 1, back 1 right there. And so, whoops, so there's our 3 dots. Again, we went down 1, 2, 3, 4, 5. We went left 1. And the reason why we did that is because of the down 5, and that means left 1. You can also use your calculator. And so then we're going to go ahead and come along like a snake, go through the dots there, and then over to the right, over to the right. Perfect. So that is our cube root. The domain is -50, positive infinity. So I think we're just graphing on the test, but be able to do domain and range too. But I think we're mostly just graphing on the test there. Okay, so then 27 we'll do on our calculator to show you how to do that. So then let's zoom out a little bit there. So on the calculator, there we go, that's a bit better. So I'm going to clear my graph, pushing this clear button. And then we're looking, there is a cube root. So you go to the math button, you go down to cube root, there it is, option 4 is cube root. So math, again, math button, option 4 is cube root, beautiful. Okay, so then we're going to type in x minus 2 inside, x minus 2 So x is right here. Excellent. So x minus 2. There we go. So that's x minus 2. Right arrow to get out of the radical of the cube root, and then just do a plus 1. So we're going to go plus 1. There it is. So we push graph, and it is a shift to the right 2 and up 1. Beautiful. So that means we're going to go from the center of our graph. Let's go and zoom in again. There we go. So center of our graph. There it is. So we're going to go right 2, because negative 2 means right 2, opposite, and then up 1. That's the center. We're going to go over 1, up 1, and down 1, back 1, and that's cube root. Beautiful. So then we'll go along. Whoopsie. Try to make it a little bit more straight there. It's actually slowly going downward. So we're going to go along and then up, a little zigzag, and then along like that. And so there's number 27. So last one is 28 and 29. So there will be matching, hopefully, there on the test for you, but know how to do it by hand as well, which is awesome. So here's 28, and so it's asking us not to match, it's asking us to graph it, which you can do an XY table if you want to, which is what I teach in class. Or you can actually do just graphing the line and looking at the boundaries, which I think is actually easier, really. So we're going to do y equals negative a half x. We're going to do y equals x, and we're going to do y equals 3 minus x. Awesome. So let's go and take a look at that y equals half x, okay? So that is a slope, right? So that's just got a slope of 1 over 2, so up 1 and over 2. There's no y-intercept, just starting at 0, 0. So then I would go to the center of my graph. I would go 0 where the y-intercept is, really lightly now because we're not sure where the boundaries. Well, you can see it. Look, there's boundaries at negative 4 and positive 4. And so I would go back 1, 2, 3, 4, and just kind of there's going to be a boundary where the line, the graph's going to change. And then positive 1, 2, 3, 4, little boundary, just real lightly where the graph is going to change. Okay, so then this says everything less than negative 4, right? Less than negative 4 is actually this way, right? Negative 4 and to the left. So then I'm going to go ahead and think, okay, so I need to start at negative 4. Excellent. And so my y-intercept is at 0. And then I'm going to use the slope, which is up 1 over 2. Up 1 over 2 over. So that's up 1 over 2. Up 1 over 2. But we actually don't even want to be in this area anyways at all. We want to be over here. So we're actually going to go backwards then, which instead of up 1 over 2, we're going to go down 1, back 2, which is the same. Down 1, back 2. So we're actually going to start at negative 4. And so, but as you can see at negative 4 is not less than negative 4. So it's going to be an open hole there. It's going to be an open hole there. Open. You can even write it, open. Okay, so that's an open hole right there. And then we're going to keep on going, following our slope. Keep on following our slope. So we're going to go back 1, and then, down 1, back 2, down 1, back 2. And so since it says all numbers less than negative 4, that means negative 5, negative 6, negative 7, negative 8, negative 9. We're just going to keep on going with that line. And there you go. There's the first one done. The next one is just going to be y equals x from negative 4 to 4. So now we're going to go from negative 4, which is right here, to 4, which is right here. But we're going to use the line y equals x. So what is y equals x? Y equals x is just plug in 1 for x, you get 1 for y, right? Y equals x. So you can do an xy chart if you want to. Put in a negative 1 for x, you get a negative 1 for y. Put a 2, 2, negative 2, 2. So just going to plot those dots all the way to 4 actually. So we're going to go ahead and start off. We can start off at the y-intercept, which in this case y equals x plus 0, so just 0, 0. But this time it's going to go down 1, back 1, and over 1, up 1, right? And over 2, up 2. So you can start to see a diagonal line, and you're going to go all the way till we get down to negative 4, right? Because we're going from negative 4 to 4, closed dot because of the equal to. So it's going to be a closed dot and a closed dot because of the equal to. Okay, so here we go. So we're going to go all the way up to there. And so there's that line, which is nice. It's a closed dot because it's going to fill in our hole for our domain, which is really nice. Awesome. Okay, so then next we have y equals 3 minus x. And so let's kind of reverse that. What is that actually? That's y equals negative x plus 3. Right? 3 minus x is the same as